All right, class, let's go for it. So chapter 5, it is factoring. Very, very important to do. But you kind of have already done this with numbers. We've done this ever since you've been factoring numbers or multiplying numbers. So remember in chapter 4, remember how we were multiplying these together with FOIL method? Well, I'm sure you guys learned, let's see, what is it? I think it's grade 3. Remember grade 3 you learned 3 times 5 is 15? And then I think it was grade 7 where you learned how to factor. So then what you did is you went from 15, you broke it down into its prime factors. That's exactly what we're going to be doing, except now we have variables on our hands. That's what the extra. So really what we're doing is this. We're breaking down numbers into its prime factors. We're breaking down polynomials into their prime factors. The same exact stuff, just got this little x thing in there. That's happening. All right, so let's go for it. That's what we want to do. We want to go from x squared plus 5x plus 6, and we want to break it down into what you would FOIL in order to have this. Good there? Does that make sense? So we're really chapter 4 in reverse. That's what it is. Cool. All right, so let's go for it. First things first, in chapter 5.1, we're going to learn the greatest common factor. What is that? And then we're going to learn a process called factoring by grouping. So we're going to learn two things here. Again, we're just piecing it together until we get to 5.6. Once we get to 5.6, then we're going to put it all together here. So, greatest common factor. What is it? It is the largest monomial that can actually divide into or factor into each of these terms. And so the easiest way to do this, so really what we're saying is what is the biggest number that can multiply into those terms? Or say it another way here, what can I take out that if I distribute would give me this? Good. So it's really anti-distributive property or reverse distributive property. That's what we're doing. So let's look at numbers here. 4 and 6. What's the biggest number that will go into 4 and 16? 4. So 4 on the outside. Now how do we handle this? We have x to the 5th. We have x to the 3rd. What's the biggest number that can go into both of those? Has to be a 3rd, right? Because it's x to the 4th. Again, there's no multiplier to give me x to the 3rd if you have x to the 4th already. So if you want to write down something, maybe write this down. Whenever you're dealing with variables, you always go for the lowest exponent. Always, always, always lowest exponent. Okay, once you have that monomial sitting on the outside, then we just say, what's left over on the inside? Now you already have the 4, so no need to do that. X to the 3rd, I need x to the 5th. Remember the rules for exponents from last chapter? All we got to do is add them up. So if you have 3, you need to go to 5, you just need 2. So you need an x squared. Minus sign comes down. 1 multiplies 4 to give you 16. 4, and then do we need any more x's? Nah, we have 3, there's 3, so therefore it is done. We have factored out the greatest common factor. Cool. That's like distributive property in reverse. That's kind of what we're doing. Cool. Okay. This is the first problem of the first section of chapter 5. It better be the easiest one. Okay, let's jump to this one. Multiple variables. And now I have 3 terms. So this is a trinomial. I'm going to go kind of quickly here because I do want to finish within the hour. Alright, so if you can stay ahead of me, if you want to stay ahead of me, go for it. Okay, but at least keep up with me the remaining time. So let's go for it. I got 3 terms now. This one, and this one. In this case, alright, let's go with the numbers of 5, 15, and 25. Everybody agreed with 5 on the outside? That's the only number. So now let's go with the variables. Easy here. A to the 5th, A to the 3rd, A to the 1. Just A to the 1 gets to go out. B cubed, B squared, and then B to the 4th. B squared. And then open up that little parenthesis to tell you what is left over. So 5, already have it. Let's see, I got a to the 1, I need to go to a to the 5, so therefore I need a to the 4 still as a multiplier. Remember, because if you multiply numbers, all you do is add exponents. So this is easy. This is more like just a subtraction and you're done. So again, b to the 2nd, I need b to the 3rd, so therefore I just need an extra b in there. minus sign. Let's see, 5 times 3 gives you 15. I need, let's see, I need an x squared to give me to a cubed. I'm sorry, I need an a squared to give me to a cubed. B squared, I already have it, so no more b's needed for that middle term. All right, plus sign comes down. 5, perfect. I don't need any more a's, that's taken care of. B squared, b to the 4th, I need another b squared, and closing it off. Alright, so those are the sort of the introductory ones. The next problem here, just a sort of quick one, just to make sure you got it. So like an easy one. For this section, yeah. Or for this part. Okay, easy one, all yours here. Factor out the greatest common factor. Just to make sure we got it, then we'll work our way through a few more extra problems here. Alright, and it should be that easy. So 4 and 24, 4 gets to go on the outside. Leftover should be x plus 6. That's what we're doing. So really, distributed property in reverse. Okay, of course we're going to get a little more interesting here. This one let's do together here, because there's a little nuance here that needs to be explained. Alright, let's go for it together here. This one's going to be a little bit different than the rest we've done. So 6x to the 4th, 48x to the 6th. So let's see, for the 6 and the 48, hey, 6 can do it, right? 6 can go into 48. 8 times, I think, yeah. Yep, and then x to the 4th, x to the 6th, x to the 4th gets to go out as the biggest number. So notice what we've done. This whole first term actually came out. Okay, in this case, we still have to have a multiplier here, and the answer is going to be 1. If the whole entire term goes out, your multiplier still has to be 1. I'll show it to you in just a second here. Plus sign comes down. So 6 times 8 is 48. X to the 4th, x to the 6th, I need x squared here. Okay, it has to make sense, because when you're going to do the distributive property, you still have to get to the same answer. We good? So when you distribute here, notice what's going to happen is you're going to get that 6x to the 4th back. That's what you want. If the one was missing altogether, then that would make sense. You would not get the same answer back. Okay. I think the next one you guys can try by yourself. Go for it. A little easier one. Alright, out of curiosity here, what did you guys pick as the greatest common factor to factor out? 3x squared, right? Okay, cool. 3x squared on the outside. And just to verify, 7x cubed minus 5x plus 2. Again, trying it yourself, make sure all those numbers work out. Ask me if there's a reason, or ask me if something does not work out. Alright, and the next one here sort of incorporates everything we've learned so far. So I'll let you guys try this one yourself first. Multiple variables. again, if you get this problem, then you got it. All right, real quick here. What is the greatest common factor? 8x squared y. We good there? And then as you multiply everything back in, the last term is the one that's sort of a little bit complicated. You have to have that little 1 all the way at the end. So it sort of incorporated everything we've been learning so far. All right, any questions on that one? Everybody good? All right, how many, just real quick, show of hands, how many got that one right before? Show the answer, okay. About 60% of the class, okay, we're good. All right, let's change gears here for the second part here. So now let's look at factoring by grouping. Anyway, I think I'm gonna do this here. Just jump to this. This is factoring by grouping. Got to the next level, that's cool. Okay, let's go for it. Factoring by grouping. So first of all, you should notice something. In all 4 terms, can you factor out a greatest common factor? Is this something that's common to all 4 terms? Yes or no? What do you guys say? No, there's 5's over here, but not 5's over here. There could be x's, because x is over here, but then there's no x at the end here. And there's no y's over here. So can't factor out a greatest common factor. But this is actually called factoring by grouping. Notice you have 4 terms. I still want to be able to sort of put it into these 2 parentheses. I still want to factor it down. So if you do have 4 terms, sometimes what we can do is we can group them. And that's why it's called factoring by grouping. We group them into 2 pairs. You always want to start off 2 sets of parentheses with a little plus in the middle. That's how we started off. The first 2 terms, x squared plus xy, these 2 terms go inside the first parenthesis. The last 2 terms go inside the second parenthesis. So instead of dealing with all 4 terms at the same time, now we're going to just deal with 2 at a time. So x squared and xy, x is common there, leftovers. I'll go like that, so x gets to be factored out. We need another x for the first term, plus I just need a y for the second term. All right, plus comes down. What's common in the second parenthesis?
5.
Yeah, 5 gets to go out, leftovers. Hey, that's cool. So now notice that this term here, and again I say it, this is just one single term here, one single term. What do these 2 terms have in common now? Yeah, this little x plus y. So this is exactly what we're going to take out this little parentheses of x plus y. So parentheses x plus y gets to go out of both of these guys. Then what's left over for this first one? Yeah, just this x. Leftovers for the second one. That little plus 5. Hey, cool, we factor that down. Now they're in terms of just pieces that need to be multiplied together. Okay, good there? Let you guys try the next one here then. All yours. Again, set it up 2 parentheses with a plus in between. Alright, let me go with it here. So 2 parentheses, plus sign in between. First 2 terms go here, so 3ax minus 2a. How about a 3bx minus 2b? Alright, the first one here, 3 and 2 have nothing in common. A is the only thing in common here, right? A. This guy does not have an x, so A is the only thing that goes out. Leftover is 3x minus 2. Go to the second one here, looking at that, 3 and 2, nothing in common. X, nope. But B, yeah, B's in both of them. So how about let's take out a B. Leftovers will be a 3 and the x still here, minus, and then the little 2. And voila, there it is. Now you have that. In Math 63 we call it a binomial factor, which means it's a factor that has 2 terms in it already here. So this binomial factor is the common factor, 3x minus 2. Leftovers a plus b, and I factored it down. Cool. Let me take a look at yours here. Okay, so that is 5.1. Now we're jumping to the next, again, piece in the factoring puzzle, 5.2. In this we do quite a bit. We factor trinomials. So 5.2 are the very easy ones. 5.3 are the more challenging, difficult ones. That's kind of what we'll handle today. Alright, so let's talk about it here. So in in chapter 4, what happened was, we were multiplying this out, right? Remember, let me grab this. X times x gave us this guy here. And then we multiply here, this gives us a 4x. This gives us a 3x. And notice what we have is we have a 7x. Right? Remember, because the middle terms always used to be like terms. And then the end one, that's where the 12 comes from. So if you think about this here, really, if I'm going to go backwards now. So if I see an x squared plus 7x plus 12, I know the only way I could have got an x squared is if I had an x in front of each of those terms, right? There's only one way I can get that x squared, is x times x. The difficulty comes in is understanding where these numbers come from, and this should be pretty easy to see here though. 7 is really a 3 plus 4, and 12 is really a 3 times 4. We good? So that's where they're easy. As long as you can get those little factors, you're good to go. Okay? And so what we do, and I'm going to do it a little differently than what the book does. In fact, there's 5 different ways to do this factoring. There's 5 different factoring techniques. There's the box method, the area method, the X box method, the X factor method. I like this little X factor method. This is not the way the book does it, but I think this is the most simplest, easiest. After teaching a whole bunch of students, this one is most students just gravitate to this, which I think probably you guys have seen in high school somewhere, right? Cool. So what we do, in order to go backwards, what we do is we take this 12 and we put it on top. So whatever we're multiplying, we put on top. Whatever we're adding to, we get on the bottom. And then it's a guess and check game, just guessing game. But if you know your multiplication tables, it's pretty easy, right? 6 and 2 makes 12, but it doesn't add up to 7. 1 and 12, 4 and 3, yep, 4 and 3, there it is. So it's things that if you want to put in more details here, it's a multiplication symbol or a dot on top, and it's a plus symbol for the bottom. Okay, with negative numbers, it works the same way though. So I'm looking at this, x squared minus 3x minus 10. And so I put the negative 10 on top, the negative 3 on the bottom, and the question is what 2 numbers multiply to negative 10 add to negative 3? Okay, and also what I want to show you here is the whole concept of signs. Signs are very important here. So let's go back up to the first one here. If you have something on top that's positive, if you multiply things that are positive, you only have 2 choices. Either these 2 numbers are both positive, or these 2 numbers are both negative. Does that make sense? If you're out multiplying 2 numbers, and you get a positive answer when you multiply, They either could be both positive or both negative. So really, this top sign, the sign for your multiplication number, tells you whether the signs are the same. The bottom number tells you what sign they are. So if this was a -7, only change would have happened is this would have been a -3 and a -4. You still would have got a +12. Cool. So that's for same signs. What happens if you have a negative number on top? That means you have different signs. But then you also have a clue here. You have different signs, but then when you look to the bottom, you know that's a -3. You know the bigger number or the bigger factor is going to be negative. Right? 5 turns out to be the negative because when you add these guys together, the negatives have to win out. We good? So there's a few little clues in here that just sort of would make sense as you go through it. Anyways, we're going to do some practice problems here. That's 6 problems altogether. So let's try them. Hey, look at that, number 1. Very similar to, I think you guys seen something like that before. So I'll let you guys try it, go for it. Maybe give you guys 30 seconds for each slide, and then I'll give you the answer. Right, good enough. Okay, so the first one we technically already did. I just want to practice with you guys here. So 12 and 7, you know it's going to be a 3 and a 4. So you set up the parentheses already. At that point, you know it's going to be an X in front, so you can even set that up already if you like, even before you do the X box. But eventually you're going to get a +3 and a +4. Okay, in the textbook, it may be that it looks actually different because when they do the X box, it may be that they put the 4 here and then 3 over here.
Or the 7 on top and the 12 on bottom?
Usually the 12 and the 7 are standard. The multiplication is on top, addition on the bottom. Okay, but the answer in the back of the book could actually look like this. Those two are the exact same thing. Doesn't matter which, as long as you have that, as long as the stuff inside each of the parentheses is the same. It's kind of like saying what's the factors of 15. You could say 3 and 5. Someone can say 5 and 3. It doesn't matter. Both are correct. Okay, second one here. Hopefully you guys did that. -20 and a +1. Sometimes what I like to do as well is to write down the sign with the number because it sort of keeps me on track with if it's positive, negative, so it make sure that I'm on track with the signs. But anyways, -20. That means I have different signs, and then the bigger one's going to be positive. And I give myself a 5 and -4. X + 5, X - 4, or X - 4, X + 5. Again, doesn't matter. So if you see the answer slightly different than yours, like that, or reversed in order, that's fine. Okay, the next two, let's work through the first one together, and then the second one's yours. I'll give you a hint if you want to do it yourself. Something about greatest common factor. Greatest common factor. All right, doing number 3 together here. Everybody hopefully noticed, hey, you know what? A 3 can go into all of these numbers here, right? So 3 has to be factored out first. Leftovers with an x squared plus 4x minus 21. Hopefully you did that. Those that want to go ahead. So 3 went out. Then we're going to deal with just the stuff inside the parenthesis now. So then I'm going to deal with a negative 21 up on top and a plus 4 on the bottom. So I need 2 numbers multiplied to negative 21. I know the signs are different, and I know the bigger one is positive. Anybody with that one? Cool, yep. 7, negative 3, or negative 3 and 7. Either or is fine. So then don't forget to bring the 3 down. Students like to forget that for some reason. They're into the Xbox. They think it's so cool. They do that, and they forget the 3. So x plus 7 and x minus 3. That's the final answer. Again, those are that went ahead of me. Try number 4 by yourself. Give you guys a little bit of time. All right, look at this one here. Let's see, I see a 2, 18 and 16, so I'm going to take out a 2. I see x cubed, x squared, and then x to the 1. So there's a common factor of x as well. If you forget to do the x, everything else, it's wrong. You won't get the numbers that you want. So it's very important that you take out the greatest common factor. You got to take out the biggest number. All right, let's see, a 2 is here already. X, I need to go to x cubed, so I need an x squared. I need a minus 9 to give me to negative 18, and an x plus 8, right? Yeah, 8. Cool there. Perfect, yep. Positive 8 and a negative 9. So this one's an interesting one. Notice the multiplication on top is positive, so it's either be both positive, both negative. But I looked at the bottom, I said, oh, both are going to be negative. Then I'm really just dealing with the numbers then. How can I multiply 8 so that adds to 9? It has to be 8 and a 1. All right, 2x on the outside, don't forget that. And x minus 8, x minus 1 as our final answer. Good. Cool, all right. Got a few people still writing it out, so let me wait a little bit. All right, the next set, or the next pair of problems here has to do with multiple variables, and I got x and y at the same time. How do we do this one? Well, first of all, you have to notice something. If you notice this, you have to notice how the x's are structured and how the other variables are structured, how the y values. So let's look at the x's first. Notice you start off with x squared, then you go down to x to the 1, and then you don't have any x's whatsoever. This progression, you go from degree 2, then degree 1, then nothing, or degree 0. For the y's, you have the exact opposite. You have no y, so this is really y to the 0 power, y to the 1, y to the 2. We good? So one of the variables has to go 2, 1, 0. The other one has to go 0, 1, 2. If you have that, then you can factor this guy down. Okay, first things first, x. How do you get x squared? X times x. That's the only way to get it. Now, how do you get y squared at the end and going in reverse order? We'll get there in just a second here. Let's deal with the variables first. The only way you get a y squared at the end, that means you would have had y at the end for FOIL, for the L of FOIL. So once you got the variables all taken care of, now the question is the numbers. So I got a 6 on top, boom, 5 on the bottom, boom, and then we just deal with the numbers only. And or 3 and 2, or 2 and 3. All right, we're going to put this little plus 2. The 2 has to go in front of the y. So it's the coefficient for the y value, coefficient for the y value on the other. And done. If you're ever in doubt, like, I'm not sure if I did this correctly, you can always FOIL this out, right? Because this is just reverse FOIL. Multiply x times x, there's your x squared. X times 3y gives you 3xy. 2y times x gives you 2xy, and that better add up to 5xy. And then notice 2y times 3y, if you multiply these guys out, would give you that number at the end. So yeah, it better FOIL out to the problem itself, or else something went wrong. So okay, number 6, all yours, go for it. Alright, let's go for it here. So first things first, let's deal with the x squared in front. Let's deal with the y squared in the back. And now let's deal with the number itself, -8 and -2. Anybody? -4 and a +2 would do it. Yep. Multiply to give you -4. And then add, which is a -2. Awesome.
I had it and I questioned myself.
Ah, don't do that. Okay, so those were the easy ones. And if you thought, Mr. Hayes, that was pretty good, easy. That's good. Now let's move on to the more challenging ones here. So what makes it challenging is that, see how in front you just have an x squared? What happens if I put a 6 in front of that? What happens if I put a 4 in front of that x squared? The trouble is that it affects this little middle term. That's the problem. And so in that, so 5.3 more trinomials to factor. And so because you have this little 2x in front, remember when you do the outside terms and the inside terms? Now you have a multiplier of a different coefficient. Now when you do 2x times 1, now you have a multiplier of 2x that's being added to that middle term. But on the bottom, notice that right here, if you put the -3 at the end, 2x times a -3, now you got a addition of a -6x to that middle term. So that multiplier starts affecting what's going to be in that middle term in front. So let's practice. Let's just do a few here. I think we'll get used to it as we do it. So factor this trinomial. I got a 6 in front of the x squared. Bummer. Okay, so first things first. You want to start off, and you want to start off as in the most organized way you can, and you sort of build on it in an organized fashion. Cool? So you'll see that from me. Let's see what else. And this is called a guess and check method. So what we do is we guess it, we check it. If it doesn't work out, we scrap it, move on to the next one. Guess, check, scrap, until we finally get our answer that we want. Okay, so let's go for it here. So can no longer do x times x because of that 6 over here. But we can think about, okay, what numbers would multiply to give me a 6x squared? Yep, 2x times 3x or 6x times x. That's the one that most students sort of forget about. Remember, you could do a 6 and 1 as well, right? So, but I got this side, and then on the other side I got my 2x and 3x. Cool? Those are the only ways I can get a 6x in front, 6x squared in front, right? Okay. Once I finish that, then I turn my attention to this 4 at the end. So the good thing is I don't see any negatives here, right? So I don't have to deal with negative signs or positive signs. We'll get there a little bit later. But this 4, see, okay, hold on real quick here. Factors for 4. 1 and 4 can give me a 4, and 2 and 2. So I have 2 different possibilities for that. So really there's 2 different possibilities for the 6x squared. There's 2 different possibilities for the 4. So I'm going to just pick one of those. So I'm going to pick 4 and 1. And yep, it's sort of random. After you get sort of used to this, you sort of get a feel for it. Like, oh, you know what? I bet you it's going to be this. And of course I'm going to do the one that doesn't work first. Okay? So let's go for it. So once you've picked your guesses, now it's the check time. You already know how you got the 6x squared. It's the 6x times x. You already know how you got the 4 times 1. It's this middle term you got to check. So it's really the outside term, 6x times 1 is 6x, and the inside term, which is 4x, and you're checking to make sure it adds to the 11x in the middle. And I don't think so, right? Yeah, 10x. That does not work. So what we're going to do, before we start changing numbers around, let's take that 4, let's put it over here. Let's take this 1, put it over here. So let's just switch the numbers around. So +1 there and a +4 over here now. Okay, also, eventually what you're going to do, you're going to be able to do it in your head. Because once you put this down, or sort of think about it in your head, you're gonna, as soon as you do this, you know you're done, right? You're at 24x, and then you're going to add some more? I don't think so. That's not going to give you 11x anyways. So that's done. Okay, 4 and 1, and then we flipped them. That didn't work. Okay, how about 2 and 2? So +2 here, +2 here, because that gives you also a 4 at the end. And some people are saying no already.
Could use the X factor on this. You times C.
Uh-huh.
B
I'll show. Yeah, I'll show it later. So 12x plus 2x, 14x, not going to work. So that's the I've exhausted my possible factors of 4. So then I go on to the next one. And guess what? I'm going to use 4 and 1. I'm going to use it in this order. So I stay organized. If that doesn't work, then I'm going to switch the 4 and the 1, put the 1 here. So that means I'm organized. I can keep them sort of in an organized fashion moving through this. Okay. Multiple outside terms, 3x times 1, 3x. 4 times 2, it makes 8, so 8x. Hey, there it is. I got it. There's my 11x in the middle. Perfect. So final answer, 3x plus 4 and 2x plus 1. Okay, there are 3 different ways to do these problems as well. There's a sort of more complicated Xbox method. I won't show you that to the end because I want you guys to sort of get the feel of sort of guessing and checking. And then there's a certain feel you sort of get for these numbers after a while, and that's probably more of, it kind of builds your math fluency in it, as opposed to just kind of going through a certain routine and be done. But I'll show that to some people that really want to know. Okay. Next one is all yours. Go for it. This one's easy because 7 is a prime number. So the only way you can get a 7 is 7 and 1. 2 is a prime number at the end. So the only way you can get a 2 is 2 and a 1. Now I did stick in some negatives in here. But I want you guys just to try it. So of course, the honesty question. Mr. H, I can honestly say I read 5.1, 5.2, 5.3 before I came to class today because I knew we were going to do 3 sections really fast. I knew I better study and know this. Donut today, okay. And then how about this, Mr. H, after seeing 5.1, 5.2, 5.3, I wish I would have read ahead. It would have been so great if I... All right, we got 10 people that want to repent of their ways. I see still pencils going. Got a few people done already. I'll wait just a little longer. All right, I'm going to start here. I do want to show you something as well here, so kind of pay attention. Even if you finish off the problem, you got it correct and everything, I just want to show you something. So, 2 parentheses, 7x squared. The only way I can do that is a 7x and a x, or a 1x. I'm that -2. Again, you got to deal with the negative sign here too. So sometimes you have to switch the negative sign and sometimes you don't. So I'm going to just randomly pick a -1 here and a +2 there and see what happens. All right, and I'm going to go outside terms. That's going to be a 14x. And then inside term gets me a negative x. So if I add those together, it gets me a positive 13x. Notice, but I want a negative 13x. So then I know the only thing that's wrong is my signs. I got the exact opposite of what I wanted. So I don't even need to check the next time. I could just do this 7x plus 1 and x minus 2. All I do is just switch my signs on it. It's going to work out. For sure it's going to work out. Just to check though, now I have a negative 14 and I'm adding a positive 1, which would give me a negative 13. Cool? So if you get the exact opposite of the number in the middle, all you got to do is switch the signs. Okay. Got a few people writing stuff down still. Wait a little bit. Okay, next one. I got a little bit of a hint for you. And my hint to you is something called the greatest common factor. Greatest common factor. All right, anybody have the greatest common factor, first of all? 4. Not just a 4?
4x.
Okay, cool, 4x, okay. So we have the leftovers. There's the first term again. Greatest common factor always has to be done. If you don't do that, then you're not going to be able to factor stuff down later. Okay, so I have trinomial left over, and now I have y variables, but that's okay. All right, 2y squared. The only way I can get a 2y squared is with a 2y and a y. And again, negative 2, put that in there somehow. And again, I was doing this in the earlier class, so I did a plus 2 here and a minus 1 there today, and that didn't work because, let me go back real quick here. That gets me a negative 2y plus 2y, which would give me a 0 in the middle, and that's not what I got. So then I had to switch the numbers around. 2y minus 1 here, 2y plus 2 there. And let's see if this makes sense now. This becomes 4y minus y, which is 3y, which is the exact opposite of what I want. Cool, so that means I just need to switch the signs and I'm good. So 2y plus 1 now, 2 and a y minus 2. And again, your direction could have went differently than mine. That's okay. Alright, and this one, let's see. Something about greatest common factor. At the same time, multiple variables. Whew. Okay, how about this? I'm just going to let you guys try this here. Give you a minute here. Try it yourself. See what you come up with here. I think what I did is I just gave the answer here, so go for it. Work out yourself. If you think you got it, maybe check with the person next to you just to make sure if you guys got the same thing here. All right, let's go for it here. So the answer should be that you factored out a 5y because of greatest common factor. And then you factor this down. Let's see, I needed a, 6x squared. Give you a little hint here. Whenever you factor in this first term, not all the time, but I would say if I had a choice between a 6x times x and a 2x times 3x, I probably would choose 2x times 3x. We're good? I'd choose the middle factors as opposed to like the 6 and the 1. Does that make sense? Because most time it'd probably be the middle factors. Not always, more like 60-40. 60% most time it would be that. So I'll probably choose this one. I'll probably try those first. Hey, this is fun because there's a little 1 right here, right? So technically it's a -1. So because I have the y squareds at the end, I know I'm going to have y variables. And then it's really either a +1 or a -1, whichever one's going to work. I do it this way here, and it turns out to be true. This is a 3xy minus a 2xy, which would give me a +xy. And there's my final answer.
So why did you go with the y again?
Why did I do the y? At the end, you mean?
Why did you start with the y, 5y?
Because I had a greatest common factor to deal with.
Right.
Because that one,
Oh, we chose
35 and 5. And then I have a y here. I have a y squared and a y cubed. So I have a common factor of at least y in all the terms.
Okay, there you go.
And then the rest came down and the rest
Okay.
filled in.
It was close. I thought about that, but I didn't.